This episode is produced with support from DBT Wellcome Trust India Alliance.
Hello and welcome. This is the Nature India podcast, and you are with me, your host, Subhra Priyadarshini. We are really coming to an end of this season and this series of podcasts called Our Mobile World, where we had a really good conversation around how the mobile phone has quite sneakily taken over science, how we do research, how we provide healthcare, how it has impacted agriculture and biodiversity mapping, among many other topics. Some really fascinating stories. We also heard extensively about the flip side of using mobile phones, the problem of e-waste, the digital divide that does not allow a very large population across the world to access technology or its benefits, so to say. Those were eye-openers too. In our final episode this season, therefore, we are going to look at what the future of mobile phone technology and services hold for us. Where are we really going with newer cell phones? We have all seen sci-fi interpretations of mobile phone technology where you just wave your hand in the air on a screen in ether and your phone or whatever gadget it is going to be called in the future basically obeys your command and complies. And then throw in the strides we are now making in artificial intelligence, and perhaps it is going to be an invincible tool in the future then. So, to talk about all of this, we are with Nilesh Mehta, who is a professor and chair at the Electrical Communication Engineering Department at the Indian Institute of Science, Bangalore. He has just come out of a class teaching wireless communication to his students to speak to us. I understand you and your group work on next generation cellular mobile radio systems such as 5G, new radio, and wireless systems. So please give us a sense of what all that entails and what you think the future of mobile telephony is.
Essentially, if you look at how cellular technology has evolved, we've gone from 2G to 3G to 4G to now 5G. The companies will start standardizing 6G in about 2 years from now. So the standardization will happen over 2 more years after that, and 6G will be out. It's essentially every decade, roughly, you move from 1G to the other. It doesn't mean that between 2Gs nothing happens. There are, of course, improvements that are done in the form of what are called releases. Broadly, the way I see it is more and more wireless will disappear. Disappear in the sense that it's not there. It's just that it's such an integral part of our lives that essentially we don't notice it. I mean, already cell phones, we use it for lots of things, like you mentioned, but there's much more to wireless than perhaps just cell phones. Let me take a different example, that is wireless sensors. For example, you could put these sensors in smart meters that would make readings of your power. You could also have them deployed, for example, to remotely monitor the conditions of bridges or roadways, and then automatically log the state of these infrastructure, and then take action if required, or at least trigger somebody to take action if required. Another major thing, and this is something that 5G embarked on and 6G will embark on even more, is that it's not just communication between human beings anymore. What we call machine to machine communications between two devices is already rather big now. Industry applications come to mind, but there are many other applications. And in 5G, it was called massive machine type communications. They're talking about 1 million devices per square kilometer, that type of handling of traffic. And 6G is going to take it even further. What we're trying to do essentially in our group is help in engineering these systems so that they can meet the very aggressive goals that are being set from one generation to the other.
And you said industrial applications, of course. So, how do these advancements in wireless technology open up new possibilities for applications? For instance, like factory automation, where real time decision making and control can be quite crucial.
Let me mention two things here, and I think they're rather pertinent to this point. If you look at the way 5G was designed, a big change in the philosophy of the design of the system compared to its counterpart or its previous version, which was 4G. But it was being designed to handle, not just to give you higher data speeds, much better experience, but also to handle new vertical, industry being one of them. And the way it does it is by beginning to support newer classes of services. One of these classes of services was these massive machine type communications. But along with it, there's yet another service called, rather long name, ultra reliable low latency communications. And the idea is that you would now be able to send wireless information with very low latency. That means with very low delays and with very high reliability. We're talking of at least 2 to 3 orders more reliable systems than what is now. And this is a big deal because if you have capabilities like this, where machines talk to each other, you have very low latency. Latency earlier was tens of milliseconds. We tend to measure it in milliseconds. And they're now pushing it down to the order of milliseconds. You can do lots of new applications. For example, one big application is factory automation, where not only would you collect information from your sensors, but then use that information to make decisions and control a few processes that happen. And you definitely want to make sure that there's not too much delay between the time when you make the decision and the time at which that decision is communicated to the device that actually makes the action.
We are also coming back to Rob Stray, who is the Chief Technology Officer and co founder of a smartphone app called Plantix. We had him for another episode in the series that focused on enabling precision agriculture for farmers. Now, Rob, as far as applications are concerned, what do you predict is going to happen, especially for apps like Plantix or the ones that map biodiversity and enable conservation?
If we talk about user interfaces, I think we're moving towards making our apps more user friendly with conversational interfaces that allow for voice and speech interactions. This change is designed to make our app more accessible to like a wider range of users. I mean, simplifying how they get information they need, and especially important for the tens of millions of semi or illiterate farmers worldwide. At the moment we are running experiments with like really having voice and speech based interfaces, so like a farmer can talk to Plantix in Punjabi or Telugu or Marathi or Hindi and ask a question about his cotton crop where he may not have been able to formulate it in written form, or it would have taken a very long time because he's not used to have the Telugu keyboard on his app. And so if he can like speak to the application in his mother tongue and we are then answering also in Telugu using an AI algorithm, we think that, yeah, we can like reach many more people. I'm definitely excited about the future. This is something that I would want to say, right? Like I think we're really at the beginning of a technology revolution in this very moment. For us, sub-Saharan Africa will be a market that we always wanted to go to because there's so many farmers that we could support. Now it's the time where like more and more people in these countries that also working on the field will use smartphones. So we're just adding more languages, right? So like Plantix is available in 20 languages in the moment. Out of those, 12 are Indian, but we're adding Swahili now and Hosa and Hausa. And yeah, I'm very excited about, being able to like to support farmers and yeah, in further regions of the world with technology, right? That we can scale. And I hope, like, if we would have these conversations in 3 years down the line, then we could say that we like reached like 30 million farmers or maybe 50 million farmers and supporting them with independent advisors. And I know it's not only us, right? I mean, like there's lots of excellent startups, agricultural apps, initiatives and NGOs out there that start utilizing technology to like support the poorest and like most fragile people in our society, I mean, especially farmers, right? And
Yes, of course. And with artificial intelligence and machine learning taking center stage, how do you think user experience and functionality of mobile phones or even applications will change?
like just out of experience, right? I mean, like artificial intelligence is like nowadays already changing the way we make apps. We have more than 40 developers working for Plantix, and all of them are using AI to work faster and smarter. I mean, this also makes me wonder if in the future, we all going to be more like designers of software, thinkers of new ideas instead of just like writing code. So like, will engineers become architects? I mean, for me, like personalization is like the significant shift coming with AI and machine learning. So, I mean, instead of apps that treat everyone the same, we are moving towards offering a unique experience tailored just for you. I mean, so like in the past, we showed every user of Plantix more or less the same content. But these individuals have very different backgrounds. I mean, some are researchers with a PhD, others are agricultural extension officers or large scale farmers. but the vast majority of our users have never attended university. So like AI will make it possible to adapt the content in real time to the skills and experience of the user. So whether it's going to be a farmer without a high school degree or a professor at one of India's excellent universities, like I hope we can like build a personalized farming assistant for everyone.
That is, of course, very, very important. I want to go back to Nilesh to ask, as we work to build these high efficiency, personalized systems and automated industrial decision making and controls, really, are we also thinking deeply about their energy requirements?
A major new thing is energy efficiency, because the telecom sector is a major guzzler of energy. The base stations that we deploy guzzle energy. The handsets we have, of course, also use energy. So how can we make the systems more energy efficient, more sustainable? That's becoming a very important performance measure. What is happening in 5G is these networks are becoming denser and denser, which means the base stations are coming closer and closer to each other so that they can support more users and higher data rates. But you simply can't have so many base stations now on all the time. They're coming up with designs, and these are very new designs, where the base station is not transmitting signals all the time. It sends it much more infrequently and as on demand, as required. So that's one way of making them more energy efficient. The second thing, of course, is in the technology itself. If you require a given amount of energy to send a fixed amount of data, can you cut down on that by improving the communication capabilities? So that's the other thing that we keep doing all the time. Essentially, it's you're revisiting the design pretty much from bottom up.
The jump that we will see in delivery from million to billion in successive generations. Do you think that's also going to help us bridge the digital divide that we currently face especially in global south countries?
There are many technologies in the works. For example, people are also talking of what are called NTN, non-terrestrial networks. So now, essentially, high altitude platforms, as they call them, HAPS. Of course, then you've got low Earth satellites. To also, act like your base stations and then radiate signals down. One of the important things people have talked about it. I've seen many papers on this. Is essentially, can 6G improve coverage, make the signal go further to even very remote locations in a cost efficient manner? It's possible to do it even now. I mean, the question is it cost efficient to do it? And with these kind of technologies that will surely be part of 6G, I think coverage will improve, and it will be at a cost point that's certainly much lower than now. I do hope that that will, bridge the digital divide. And one of the things that people are talking about, it's a very hot area of research now, called integrated sensing and communication. Basically, currently, if you look at a 4G system or a 5G system, essentially it's meant for communication. The idea is that when you send a signal over a wireless medium, waveforms, the same waveforms can also be used not just for communication but also to sense. Sense, I mean, for example, if I am talking to you, can I localize you, pinpoint you? If a vehicle is moving, when the base station is talking to the vehicle or communicating with the vehicle, can it localize the vehicle, and as it moves, track its location, for example? Now, why is this interesting? Because essentially, you're getting double the capabilities for the same waveform.
Interesting. So, if I'm talking to you, you could also figure out my exact location. But then, don't these technologies also come at the expense of privacy and user data security?
I mean, for me, the importance of privacy cannot be overstated. I mean, that we embrace like a principle that's called like privacy by design. And this means that from the very beginning, every part of the software stack is built with like protecting privacy. For us, earning and maintaining the user trust is very important, and it guides our approach how we handle the data. So like, in other words, like the only reason that millions of people using Plantex is because they trust us and we feel honored. I mean, like, I want to be honest in here. We are using farmer data to improve our models, but we never use personal data. So let's say we have a plant pathologist and they would label images to improve our disease recognition models. Then they would see an image of an infected cotton plant and assign a disease to it. But like they would not know which farmer sent this image, right, in this very moment, or how is he doing otherwise. So like we really trying like a low touch approach and just processing metadata. I mean, we want to make farming more economical and environmental sustainable. And this only works if farmers trust us and if we handle the data with the greatest care. fears that I'm seeing is that we will just have like a couple of very, very large organizations that would be the only ones that are able to train AIs on a scale that is really successful. I mean, we still see nowadays that these most modern models cost like hundreds of millions to train. I think like, if we're looking 1 or 2 years into the future, these companies will spend $1 billion to train a model. That may then result in the point that this power will just be in the hands of few, right? Like, hence, I'm very much believing in like an open source community that can tackle this, and like hoping that we will not just have like 2 or 3 companies in the world that are able to ship this technology and everyone else relies on them, but that we have like a diverse market.
Another question from a layman user perspective that I had, every few years we change our mobile devices because something really spectacular has happened in the field of devices. The hardware itself changes quite significantly with every iteration. The software, of course, keeps changing almost every few months. Tell us a little bit about where you think all of this is going. Will these devices, the mobile devices, get even tinier? Will they get flippable, wrappable, more into wearables maybe? What do you think about the future of devices?
I think it's mind boggling now, and it's probably going to get even more mind boggling as things go further. I mean, one thing, like you mentioned, is of course, our cell phones are getting smaller and smaller, much more capable, though I think battery life remains an issue still. But definitely, going small is one thing. But I think there's much more to than just a cell phone. For example, there's this whole new category of services or technologies called AR and VR, augmented reality and virtual reality. The one big wave that happened now is that Apple has this headset that you can put, and it's supposed to be remarkable. I haven't seen it. But that requires some pretty phenomenal wireless backend capability, because these devices can't generate all this video on their own. It's just too power hungry to do that. They actually ship their measurements or their data to some server nearby, which then does all the video rendering and ships it back very quickly to the headset, which then renders it for you. So you don't even realize all this is happening while you're moving your head around. So there are many other new devices, I think, that will come about beyond the cell phone. Of course, the cell phones that we'll use will be smaller, they will be much more capable. And capability is a very loaded word in the cellular technology space. It can mean many things to many people. For an ordinary user like me, for example, it would just, for example, mean higher data rates, much better resolution on the video. But for the operator, it means something else. I mean, it means Geo or Airtel. They're able to handle much higher data rates for many more users over the same geographical area. They care about it, for example, because they pay thousands of crores for the spectrum that they use.
So, you heard it all. Your future phones will pack a punch. They will likely be smarter, faster, and far more transformative for science and society than they currently are. We will also likely see more scrutiny on privacy and data security. Love it or hate it, it is going to be a mobile future. With that, we sign off on the Our Mobile World series. Across 10 episodes, we examined, through the lens of science and research, the many ways in which mobile phones influence our daily lives. Thanks to the fantastic speakers we've had, and to all our listeners for tuning into the series and coming back for each new episode. This is Subhra Priyadarshini signing off from the Nature India podcast.
This episode is produced with support from DBT Wellcome Trust India Alliance.